All right, guys, this one, there's some hard problems in here. The first few are easy where you just have to know that the volume or the area of the base is area equals pi r squared. So for this one, we see the radius is 3. For this one, the radius is 4. For this one, it's easy. It's kind of hard because they don't give you the radius. They give you the diameter. The radius for this one is sneakily not 10, but half of that, 5. So for these first three, we can easily find the area of the base by saying, okay, this one is, the area is 3 times 3 is 9 pi. This one is going to be 4 times 4 is 16 pi. And this one is 5 times 5 or 25 pi. So you always take the radius, you multiply by itself, you square it, and then you multiply by pi. So for this one, we're going to use pi is 3.14. So we use our calculators to find those. I'll do the first one. So 9 times 3.14, I've got my calculator out. Actually, it's malfunctioning. 9 times 3.14 equals, area equals 28.26. So the other two should be pretty easy to do so far. But that's just the area of this circle down here. If I want to fill in the whole shape that's up there, I have to stretch that circle upwards 6 times. So I'm going to multiply this by 6. Because the volume is the area times, the base that we already figured out times the height of 6. So volume equals 28.26 times 6, which is 169.6. So the next two should be really easy if you just multiply. Find the area of the base. Number 3 is a little hard. And then multiply by the height. All right, so letter T is pretty simple. We have another cylinder, so it looks exactly like these ones. I'm just going to draw a really quick cylinder over here, and it says its height is 8 inches tall, and it has a radius of 2. So there's my circle base, and it's got a radius of 2. So it should be pretty easy to figure that one out. A says a cylindrical barrel is 8 feet tall. So we have the same thing that's 8 feet tall, but it's 5 feet wide at the bottom. So I'll do this one in a different color. So this one is 8 feet tall. Okay. It doesn't matter if I actually draw it 8 feet tall, but I can just say it's 8 feet tall and it's 5 feet wide at the bottom. Now, remember, we don't want to know how wide the entire thing is. Like if we look at the one above it, we just want to know how half wide it is. So this one, we don't care about the number 5. We have to split 5 in half because we don't want to know the full width. We want to know the radius, which is half the width. So that's 2.5. So this is almost like the one before it, but instead of the radius being 2, now the radius is 2.5. See if you can figure that one out. All right, for O, a cylinder is 9 inches high and has a base with a radius of 5. Okay, so we're going to go for that one. Here's my cylinder. Oh, this is terrible. 9 inches high, and it's got a radius of 5. Okay. If you fill the cylinder with half the cylinder with water, what is the volume of that? So we're only going to fill this one up halfway. So we can think of this as just at the very end, you can take the can and then divide by 2 at the very end to say like, oh, we're only looking for half the can. So whatever your answer is at the very end. Or you can say, hey, I get it, but that we still have the same circle at the bottom, but now instead of filling it up 9 all the way to the top, we're only filling it up halfway or 4.5. So the height is 4.5. So you can take the circle at the bottom and multiply by 4.5 instead of 9. So either way will work. Either you can find the volume of the full can and multiply by 9 and then divide by 2. Or you can just say, well, we're only filling it up halfway, so I only want to take my circle and stretch it upwards 4.5. So hopefully that helps. See if you can come up with that one. All right, the next one's kind of tough. W, a large cylinder is filling up with water at a rate of 4 cubic feet per minute. If the cylinder is 20 feet high, so I'm going to draw this cylinder again. Doesn't have to be the best cylinder in the world. I'm just going to trust my numbers. It's 20 feet high, and the base has a diameter of 8 feet. Now remember, diameter means all the way across. We don't care about all the way across. We care about halfway across, so that would make that 4. How long will it take to completely fill up the cylinder? All right, so this thing will have a certain size. So when you figure out that size at the end, we're going to say how long will it take to fill up with water if you can fill up 4 feet per minute. So at the very end, we're going to divide by 4. So at the very end, whatever your answer is, we're going to divide that by 4 because we can fill it up 4 feet per minute. And that'll tell us how many minutes it'll take to fill it up. So figure out how big it is. Then at the very end, divide by 4 because that we can fill it up 4 at a time for each minute. All right, G. The volume of a cylinder is 63 pi inches cubed. If the diameter of the base is 6 inches, what is the approximate height of the cylinder? Okay, so what they're telling us is we've got this cylinder, right? We've got this cylinder, and the overall answer for how much space here is 63 pi. 63 pi. Now, they didn't multiply it out, but 63 pi, so they just kept pi as pi. And they're asking us for how tall must this height be? Now, they also gave us some other clues. They said that the diameter of the base is 6 inches, so the diameter is all the way from one side to the other. Okay, so we're shooting for 63 pi, and they said all the way from one side to the other was 6 inches, but we don't care about the all the way across. We care about halfway across. So there's 3. Okay, so how tall is the height to get to 63 pi? Well, the area of the base is pi r squared. So we know our r is 3. So the area of the base is 9 pi. Okay, and when we take the base, now we know the base is 9 pi, and we multiply that by the height, we should get to 63 pi. Which means the height must be 7, because to find the volume equals the base times the height. So if we take the base, which is 9 pi, and we multiply by 7, which is our height, then we get to 63. 9 times 7 is 63 times pi. So the height must have been 7. Kind of tough, huh? Okay, this last one. Tim's job is to fill large oil silo by pouring in the small barrels. About how many barrels will it take to fill the silo? So we kind of have 2 problems here. We got to figure out the big one and figure out the small one and see how many small ones it would take to fill up the big one. Okay, so the height is 20, okay, and the radius is 30, okay. Now this one is, the radius is 2 feet, and the height is 4. Okay, so if I'm going to find the area of the circle on the bottom here for the big one, the area is pi r squared, which is pi times 30 squared, which is 900 pi. So this bottom square has a area of 900 pi. I could multiply by 3.14, but I'm not going to right now. To find the whole volume of this thing, I take that 900 pi and I stretch it upwards 20 times. So times 20 equals 1,000. No, that's more than 1,800. That's another 0. 18,000 pi. Okay, so this big one's 18,000 pi. That's big. All right, let's see the small one. The volume of the base is pi r squared, which is pi times 2 squared, because it's just a radius of 2, which equals 4 pi. Okay, now we have a 4 pi down here, but we got to stretch it upwards by 4, so we're going to multiply that by 4, and we get 16 pi. Okay, so we got to see how many times 16 pi is going to go into 18,000 pi. Well, we can divide that. 18,000 pi divided by, let's see how many times we're going to have to use 16 pi. How many times 16 pi's go into there? Well, luckily, pi on the top cancels out the pi on the bottom. That's why I didn't use it. Okay, And now we have 18,000 divided by 16. Equals 1,125 times. All right, so obviously that was a really hard problem. But the basics were there. We just had to find the area of the volume of two cylinders and figure out how many times one fit into the other. So I did that problem for you. Anyway, finish up the homework. We'll go over it tomorrow, but make sure it gets turned in tonight for full points. All right, later.